Hello everyone, welcome to AI Anytime channel. So in today's video, we are going to talk about text to video generation. You would have already seen there have been multiple generative AI models for text to image generation, and lately we are now seeing text to video generation models. So Baidu has released multiple models that we have seen, stable diffusion based model for video generation. There have been some workaround where the researchers are, integrating or combining stable diffusion with multiple latent diffusion models to generate videos. So today we are going to talk about something called Videocrafter, okay, which has been, I think, released in last couple of weeks. It is available on GitHub as well. I came across Videocrafter, I think, through a Reddit community. I'm part of multiple communities on Reddit, and so I came across in one of the communities there, and I think great time to be living, guys, honestly, because not days or weeks, as I said, now we are seeing, every hour of the day we are getting one or the other models, generative AI models. You see stable LM has been released by Stability AI, then we saw mini GPT-4 or mini GPTs, we have seen auto GPTs, we have seen Vicuna, we have seen multiple generative AI models, and it is just a start, in my views. Today we are going to have a look at Videocrafter and how we can, understand a mathematical intuition behind these latent diffusion models, or base T2V model, one of the models. So Videocrafter has three models. I will explain that in a bit. Videocrafter has not released or their technical report on GitHub repository. I was trying to find out their report so I can read that. I can try to find out what kind of mathematical model that they have been using to generate this text to video, basically the encoder-decoder model out there, but I was not able to find the technical report. It says that they will launch the technical report very soon in the next few weeks, but we'll try to understand mathematical intuition behind these latent diffusion models. How does these things works mathematically in a very layman terms, and I will not go too technical with the mathematics here. I will keep it very simple, just with some functions, how it works and how we can intuitively understand. It's very intuitive to understand this diffusion model, that how they generate images or videos based on the text description, how have been they trained on to generate this kind of data, or the text in text out. Earlier, now it's text in, images out, or videos out, or audios out. You see music LM, you see multiple generative AI models. Without wasting any time, let's see their GitHub repository. So you can see I'm currently on this GitHub repository called Videocrafter, and it has been released in the last couple of weeks. It says a toolkit for text to video generation and editing, and they are also hiring interns, guys. So if you are interested, you can ping them as well. Try to reach out to them if you want to work with them. And it says I'm interested in these three things, guys. You see, it says feature 1, feature 2, feature 3. They says Videocrafter is an open source. They are open source, by the way. That's it's very good in that way. Open source video generation and editing toolbox for crafting video content. It currently includes three type of models. So they have three different types of models here. The one is something called text to video generation, which is base T2V. So the base T2V will talk about this. They also have video LoRa, which is personalized text to video generation with LoRa. There have been other LoRa based implementation as well, that you will find on GitHub or in the community on the Hugging Face spaces as well. And the third one is video control, more controllable, how you can control the prompt. Basically, you said to enhance the controllable abilities to the T2V model, we developed conditional adapter inspired by T2 adapter. By plugging a lightweight adapter module to the T2V model, we can obtain generation results with more detailed control signals such as depth. So the depth, the pixels value, that you might see that later on. Not interested in this video control at this moment and video LoRa. What we'll do, we'll try to understand base T2V, which is a generic text to video generation by Videocrafter, which you can see over there, Videocrafter and Videocrafter. Let's see where are they from. Okay, so they are their research group. There is no details such as found here. Okay, so anyway, so you can see Videocrafter, T2V. Let's understand T2V over there here. I like to help you understand that how intuitive is this to understand. You see, they say we provide a base text to video generation model based on the latent video diffusion models, LVDM. We'll talk about this in details. It can synthesize realistic videos based on the input text description. You can see some of the prompts are here. campfire at the night in snowy forest with starry sky in the background, then close up of a clownfish swimming, astronaut riding a horse, etc. Let's understand this. They also have given a Colab notebook to run. There's a spelling mistakes, by the way, there's a typo from them. They might fix it. And we'll try to inference this model. It's also available on Hugging Face as a Gradio application. You can also find that here. They have a Gradio space. You can see Hugging Face spaces. If you want to inference this, go ahead and try it out. What I will do, I'll first understand. Here you can see I'm on this tab. Now what I will try to help you understand is with the base T2V model. So let me just write it. So I'm writing base T2V model. So that's their model, base T2V. We'll try to understand base T2V model here, guys. So suppose this is my prompt. I'll just use the prompt here. Now this is my prompt. A dog is playing in the park. Now you want to generate a video out of this text prompt. Now this is my text and I want the video. So give me a video. I'll say to base T2V, I will make this prompt and I'm expecting a video like this where a dog is playing in the park. How does this work, guys? In a very layman terms, without going too technical or too deep into it. Let's understand that. So this is my text prompt. Let me just write it over here. I'm just writing text prompt. Now this is the text prompt. What happens? We have an encoder network. I'm not going to cover encoder and decoder. I have covered it in one of the previous videos as well, where we were covering text to videos as well with some Baidu's model. You can also find it on a Transformers, Hugging Face. They have a very good documentation about encoder and decoder. Now what does this encoder network does? It kind of, let me just first write it over here, then you will understand what it does. It kind of creates different features. Now suppose concepts of a dog. Now this is one of my feature. Now concepts of playing or play, and then concepts of park. Now these are all my features. Okay, these are all feature spaces. I am calling them features that I am getting it with help of an encoder network. Now this was my text prompt. Now I'm getting different concept, different set of features here, with the help of an encoder network. What I will do now, I will just pass all these features, that different set of features that we have over here, through a decoder network. Now that will decode this feature, by the way, through a decoder network. And in this decoder network, what happens is that it generates a sequence of video frames. So this is nothing but a sequence of a video frame. So I'm just writing vid frames. It generates a sequence of a video frame. It will try to mimic a dog is playing. Dog is playing in the park. Dog is playing in the park. This is in very layman term, not going any details about what is an encoder, what is a decoder model, but what we are seeing here is a combination of an encoder and decoder network. We have an encoder network, we have a decoder network. Now in encoder, let me just explain it mathematically. So let me write it over here, how intuitive it is. Let's understand with a simple function here, very simple function. I was just reading around different papers and trying to find out an analogy that how we can create a simple mathematical function, and I came across something very intuitive. I just want to cover in this video, guys. So, and mathematics is at core of large language models. It's very important for the people like me as well, and to all of the youngsters or freshers coming out of the colleges. Please try to verse well with mathematical concept, statistics, probability, calculus, etc. to understand. It's very intuitive and interesting as well to understand the concepts behind large language models. You want to understand attention, saliency maps, etc. It's very important to understand mathematics there. Now just to come up with the functions, let's imagine we have this. Now if this is my function, now this is a very high level mathematical representation of that how we can generate video out of a text. Now what is V there, guys? If you see this V, this is a set of nothing but a video frame. So it can be V1 to Vn. This is a set. So set of V1 to Vn. Let me just write it video frames here. So I'm just writing video frames. and in the video frames. Now next is, you see this encoder of D. This is nothing but it's a function that maps. So let me just write encoder D is a function that maps the text description D. The D is nothing but the text description. They are nothing but the text description. So text description, the maps the text description. So here I am writing text disc D to set of high level features that we were discussing in the, here you see the concepts of a dog, concepts of playing, concept of park. So set of high level features. So encoder D, that you see, this encoder D is the function that maps the text description D to set of high level features. Now if I just write like this, now decoder, and this can be, now this is very high level guys, there a lot goes in this encoder D here. Now if very high level, if this is my decoder D here, okay, my decoder function here inside. Now this is a function, so it's a function that that maps the features, of to a sequence. So this is to a sequence of video frames. So now understand V, which is video frames, V1 to Vn. Then we have encoder D, which kind of maps the text description to a high level features. And then we have the decoder of the encoder there, decoder of, now just imagine if this is how we can write it this, okay. So just if I write like this, if I denote this function like this, now you'll be able to relate that we have studied in our graduates or high school mathematics, right? Now just understand like this, okay. So this is very high level overview, right? That we have a text prompt, and this is more of a training. So when the training is happening, there is video V1, V2. Now this can be frames as well. When I'm writing video, it's all frames, and they have their text description. So D1 or D2, D3, and this can be multiples as well. The way you are preparing your data, the way you pre-process your data while training this latent diffusion models, that we have been calling it LDVM. If you see here on the Videocrafter, they say, if you come down, they will say here LVDM, latent video diffusion models. It's very, very intuitive, high level view, 10,000 feet views of LVDM models, guys. Latent video diffusion model, that how encoder and decoder networks are combined, to deal with the high level features, and then that features get mapped to generate sequence of video frames. Now, so what we can do here, guys, try to inference this video to this text to video. Basically here you see they have given a Colab notebook which says an open source video generation and editing tool box for crafting video content, and let's try to run this. So I'm currently on GPU. By default, if you run this Colab notebook, it will be GPU selected here, in the runtime. So now let's do one thing. Let's run this. So the first thing is, make sure CUDA is available. So of course, if you're running a Colab notebook on a GPU, CUDA will be available, because if you use a Tesla T4, as you can see, it's a free GPU of 15 GV. If you want to use Colab, you can also upgrade it, some premium as well there. And now what they're trying to do here, they're trying to, and it is based on Ubuntu, guys. By the way, you can see if you working with Colab, it's based on Ubuntu, and that's why you can see all these commands over here with apt-get update, trying to install a couple of things. They are also checking if Python 3.8 and etc. are installed. Then we need these dependencies, PyTorch Lightning, which is a library built on top of PyTorch to accelerate the PyTorch based deep learning trainings and development. Then we have transformers, specific versions of OpenCV, ImageIO to deal with the videos of FFmpeg and all those things. Then we need MoviePy, which is a video, it's a library to handle and to do video based operations with Python. We have this library MoviePy. Let's run this. So I'm just going to run this here. It might take a little time, and it's completely depends on your internet speed and how much of space that you have. It's all VRAM here, guys, VRAM, and the memory that you have in Colab over here. You can see that. Now let's run it. Don't expect that we are going to generate good qualities or lengthy videos here, guys. All two like maximum of 5 to 10 frames that you will get, 2 to 5 seconds of video frames that you will get over here. We say I'm getting a notification from Colab which says you are connected to a GPU runtime but not utilizing the GPU. Hold on, we will utilize the GPU, guys, in a bit. And once this is done, what we will do, we'll download all models from Hugging Face. Okay, all the models and it will be saved here in the runtime in the left hand side. You can see we have a local folder now called Videocrafter. We have a models here that will store all our models, if you see currently, and this is what we are going to do. So currently I think it's downloading Torch, the specific version. There have been some version dependencies, otherwise Torch comes installed by default in Colab. Let's go to their GitHub repository, guys, and see what kind of responses that they have generated so far. Cars running on the high looks good, but all of you can see all this watermark of Shutterstock. They might have used Shutterstock images to train these models. Okay, and that's why there have been a lot of issues with the ethical domain that we have in artificial intelligence, where we see there have been talks that these models are not ethical. They are not giving credits to Shutterstock or some other stock images based platforms like Pixels, Pixabay, and FreePic, for example. They are not giving credits or CC attributes to these creators of these images that they have used to train these latent diffusion models. But now with this model, I think they would have given. I have no idea because I didn't get their technical reports. If you come down, you will see, and they have a very good documentation. If you want to set it up locally, if you have a very high-end multiple GPU based system, you can of course set it up. If you come down, you will see they have a technical report. They say coming soon, we are still working on it, so they are still writing their report. Okay, so that's in the process. If you go up, you can read about this here. Okay, now so let's see if you are able to. And Torch is huge, guys. It's around we can see it's around 1.6 GB or something here, the Torch. This version 1.12 plus 1 plus CUDA 113 11.3 version of CUDA here. Now it's also installing Torch Vision, Torch Audio, etc. Let's see how much time it takes. Let me also run the next one also, guys. Okay, so I can also run this. Now if you come down, you see this generic text to video generation. Let me explain this in a bit. So we have a prompt. You can also edit your prompt here as well, or if you change here, it will reflect here. And then we have out directory, where the output directory is in results. So they would have a results folder here that will be created if not there right now. Output results, and then we are loading these model weights and checkpoints. If you see this base path and config path. So here once we download this, we are importing this or loading it over here. And then we are running this Python inference command with multiple parameters like checkpoint path, which is base path, then we have config path, again which is config path, then we have the prompt, we are passing the prompt. Very much self-explanatory, guys. Okay, where we are saving this number of samples we want, the batch sizes, the seed for reproducibility. If you want to reproduce your results every time, you can tweak all this. Pretty much self-explanatory if you are working with data science. Okay, then we have denoising progress as well. So denoising, they have also a status message for showing this denoising progress. Okay, how much time it takes for that process as well. Now this is still being installed. I don't know if you have to rerun the runtime. Let's see that. And if you come down, then they're using IPython, etc. to visualize the video. So you can visualize it in Colab. You can also install that. Now I'm going up. This is still done. And that's the problem with large language model, guys. And if you have seen the latest interview of Sam Altman, he was saying that size is not a matter now for large language model. I think he was 5 years ahead in the future. I have no idea when he made this statement. Even with the techniques like quantization and pruning, we see this very difficult to run large language models on a local machine. When I say running, it's not only running the inference, it's about training on custom data. You need high-end GPU machines to train on your custom data and then also perform the inference task. It still takes a little time to go there and achieve those with the simplicity and ease. Now you can see what it's doing. Is downloading all model from Hugging Face. It says they're using Git LFS, large file. If you are not aware about LFS, it is a Git service for handling large files. So Git LFS comes installed in Colab. Okay, if you are running it locally, you might have to install Git LFS, and you can see Git LFS initialized, cloning into this version here, guys. Let me also click on where we are. Okay, in this this thing, you can see models install. Let me just click on this, and you can see it over here. We have LVDM, our models, this modules, autoencoder, samples. So it's still unpacking objects, cloning this repository of version 1.1, and then it will move to that T2 version inside the models. So let's wait for that, come down, and then we have this only 2 steps to inference that. Okay, what I'll give the link in the description, guys, for Videocrafter. You can use the Hugging Face. Let's open the Hugging Face spaces as well, just to show in. I hope it's a Gradio application. Yes, it's a Gradio application. When you see this status or loader here, it's a Gradio loader, and you can see they have prompts, they have models, they have sampling steps, some pre-processing steps, etc. They also given you some sample prompts here, examples, and then you can generate a video in the right hand side. So they also have, they're using Hugging Face spaces, guys, here, okay, where they are trying to show the inference. So what I will do, I'll pause the video here, and I will come back once this is done, and also maybe once the video has been generated. You see, I'll keep the same default prompt here. So let me come back when this is done, guys. So you can see, guys, here that we have downloaded all the models which are required, and also have moved to their assigned folder here, that we are using this base path and config path. And now I have used the same prompt here, guys. Astronaut riding a horse, outer space. This is one of the most famous prompt for diffusion models. Okay, so you can see it's showing you the progress and everything, sampling batches, etc. It's generating it. I think it's at the 50 steps here, and we are currently moving with a good space. Might take up to a minute or two, and we are on GPU. So even on a Tesla T4 GPU, on a sample, like we need one sample, and we have this prompt. So on a Tesla T4 GPU, guys, with the 15 GB that's given by Colab or Google here, it's still taking around 3 to 5 minutes for a video. Just imagine if you are running it on a CPU machine. I'm not sure if you can run this on a CPU machine, even for inference. So we need a high-end GPU to run all these things, guys. Okay, but anyway, let's wait for it, and once it is done, let me also run this. Okay, so meanwhile, so it will help us visualize the video. So we need to see the video, what kind of video we have generated with help of Videocrafter, which we are using their default demo notebook or Colab notebook that they have given. But the main agenda was to understand little bit about high level of how are they generating these things, guys. The high level, if you see here, that we have I'll give this screenshots, screen grabs through a link that you can have a look. Let me know if you can come up with even better intuitive mathematical function, or if you have any suggestions that how it can improve while explaining that how this works. Now let's head back to Colab, and you can see, wow, we have received here that you can see. Let me just download this this guy here. So you can let me play this, download MP4, and this is the video that we have generated, guys. You can see it's a 2 second video, as I said, few frames, max 3 to 4 frames if I'm not wrong, or more than that, whatever. You can see the quality, but we are using their base T2V model. Looks good, this is good. That's how we also started stable diffusion, guys. If you remember last year, that's how text to image was originated, with a bad quality. And then we saw Mid Journey, for example, the Apple moment of generative AI, or the Chat GPT. I don't know, people say that Chat GPT was the Apple moment, or Mid Journey. So Mid Journey was the Apple moment of generative AI for images, and Chat GPT for generative AI for text. Now GPT-4, it has more capability. Now let's, if you come back to this cell here, let's change the prompt, guys. So if I change this prompt, maybe I What can I do? A robot, for example, a robot is dancing with a girl, maybe, for example, on a street. Now this is my prompt. Let's do a shift enter here to run this cell, guys. So I will change the prompt here. Let's see what we are getting for this prompt. In this case, it will take time. Let me just go back to this, as I was saying earlier, that if you guys have better way of explaining, if you can give me some suggestion that this was completely bullshit. I was not expecting that this is how I should explain in layman terms, because I don't know much about my audience, because I'm very new while creating content on YouTube, as you can see. But I thought this is a very simple way of explaining about this, how they might have been generating these videos from a text description. But let's head back to this, and you can see all their config file, their logs here. Successfully initialize the diffusion model, and this parameter diffusion wrapper has around 958 million parameters, and then we are making attention of type vanilla with 512 channels, etc. And again this denoising progress DDIM sampler, which is having 50 steps here, will take around a couple of minutes. Let's wait for that. Let's also run this guy, this cell here. I'll give the link of Videocrafter GitHub repository where you can find their Hugging Face page, this Colab notebook, and some other information as well. So let's wait for it. This is the last video that we are generating, and you can play around it. You can use the Gradio application directly from Colab as well, guys. So you can see we are halfway done, 2550. 2750. You can see in Colab also they have in this GitHub repository where we have cloned, they have a gradio_app.py. Now you can run this gradio_app.py directly from Colab notebook. How to run it? Maybe I can give you a gist link in the description. How to run a Gradio application and how to run a Streamlit application directly from Colab using GPU as well. How can you do that? So it's pretty simple. There are multiple ways to run this Gradio and Streamlit application to run that. You can see we are almost done. 4550 steps. I think we are done now. So it's taking around 2 minutes and 50 seconds, guys. You can see here executing 2 minutes 42 seconds. Yeah, around same time. And now let's see. Oh, we have got something cool here, guys. Let's just play this, and you see a robot is dancing with another robot here. But I was saying with a girl, but I don't know if this girl is a robot or is a human, by the way, and it's very difficult to differentiate in coming years now. Okay, but anyway, you can see this robot is dancing with a. So there are two robots. One is a male robot or the other is a female robot who is dancing with each other. It's okay. It's good. I'm very happy, the way we are moving with this generative AI models. Maybe we can be a little more responsible and not about ethics here, but anyway, we can be a little more responsible while using it, and it's in our hand. But that's all for today's videos, guys. I hope you liked the video. If you like the video, please give a thumbs up, and if you haven't subscribed the channel yet, do subscribe it, and please share the video and channel with your friends and to peer. That's all. Thank you so much for watching, guys. See you in the next one.